So when input AC is applied here, this is our input AC, what kind of graph will it be? A regular AC graph, alternating current graph, right? So during positive half cycle, this is positive, that means this side is negative. So the diode, that is, when is diode said to be in forward bias state? When P side, that is this side, is connected to positive terminal and this side is connected to negative terminal. So this is when a diode is said to be forward bias state, right? So during this cycle, during positive half cycle, diode is in what? Forward bias state. That means current is going to go through it. It will allow easily current to pass through it, and you will get a similar kind of output. But during negative half cycle, the diode is going to be in a reverse bias state. That means it will not allow current to flow through it, and then what will happen? We are not going to get any output. Then during positive half cycle, we will again get the output. During negative half cycle, we are not going to get any output. So what is happening? These negative cycles are getting eliminated from the circuit. So this is how a rectifier converts AC to DC. This is a DC and it is fluctuating in nature. It is not a constant DC, it is fluctuating in nature, right? So that is how diode works. So this circuit diagram was for half wave rectifier, because it is converting only half of the cycles to DC. So there must be some full wave rectifier as well. Yes, there is. So the circuit diagram of full wave rectifier will be like this. There is another diode, and this time we are connecting these two. Okay, we are taking one connection from here and one connection from the center tapping key, and we are connecting our load resistance here, RL. Here we have our output. So what is happening? This is our input AC cycle. Let's draw the DC output cycle. During positive half cycle, let's name these diodes D1 and D2. During positive half cycle, D1 is in forward bias state, whereas D2 is in reverse bias state. So D1 is going to conduct and you are going to get an output. But during negative half cycle, this was initially negative for the first cycle. During negative half cycle, this becomes negative, this becomes negative, this becomes positive. So diode D1 is in reverse bias state, so it is not going to conduct, but D2 is in forward bias state. That means current is going from this circuit. So D2 will conduct and you will get the output again. And during next half cycle, the same process will get repeated. So this time all the cycles are getting converted into positive cycles. So this again is a positive or output, DC output. Again it is fluctuating in nature. So if we can filter it out, if we can pass this signal from the filter, you will get a constant DC. But right now this is a fluctuating DC, but it is a DC. So this is how. So this is a circuit diagram of a full wave rectifier. This is how diodes help us to make such kind of circuits, rectifier. So these are the applications of diode. Alright, so let's do a last question on diode, that is on biasing. Just in case, I want to be sure that you guys have clearly understood the concept of forward and reverse biasing of diode. See, in one statement, diode conducts easily when it is forward biased, diode does not conduct when it is reverse biased. Okay, what do we mean by forward biasing? That till this point I have told you only one thing, that if you connect positive part of the battery to P side and negative part of the battery to N side, that means it is forward biased, true. But in other words, when this P part is at higher potential and N part is at lower potential, that also means that diode is forward biased. I am giving you 4 examples. Tell me which one is forward biased, which one is not. This one is connected to earth and here it is connected to -2 volts. Second case, this is minus 3 volts and here we have minus 6 volt. In third case, a simple case of plus 4 volts plus 200 volts. And lastly, earthing and 20 volts. I want to know which of these diode circuit will represent forward biasing. I told you forward biasing means positive has to be at higher potential and negative has to be at lower potential. Alright, these are the two main points, higher and lower potential. So compare, this positive part, P part is connected to 0 volt and this is minus 2 volt. So actually it is at a higher potential, that means this thing is a forward bias state. Again, this P part is connected to minus 3, N part is connected to minus 6. So this side again it is a higher potential than minus 6. So this again is a forward bias state. Now this P part is to plus 4 volt and N part is to plus 200. Which one is greater? This is at this is at a higher potential. So this is in a reverse bias state. And lastly, this is 0 volt, this is 20 volt, N part is again at a higher potential. This will be a reverse bias state. But if it is minus 20, then this is higher, this is lower, and then it will become forward bias state, right? This is how you calculate the biasing of a diode.